Okay, so today we're going to learn about the converse of the Pythagorean theorem. You learned from Ms. Siski's video, you reviewed the Pythagorean theorem from Ms. Siski's video and learned about Pythagorean triples. And I'm sure those of you who like to do a lot of work in your head and not show a lot of work on paper already love the Pythagorean triples, as I do. And so let's go ahead and fill this in. And yes, my paper is yellow if it's not your monitor. If the square of the length of one of the longest side of a triangle is equal to the sum of the squares of the lengths of the other two sides, then the triangle is a right triangle. So it's literally the converse of what you learned in 7.1 with Ms. Siski's video, that instead of if you're given a right triangle, a squared plus b squared equals c squared, now we can use the converse of that if you don't know it's a right triangle yet, but you can prove or show that c squared equals a squared plus b squared. Then you have a right triangle. And also another thing you're going to love about this chapter is that this chapter is pretty much no proofs in it. Every year that I teach chapter 7, everyone's kind of, the people who don't care for proofs are excited that we're taking a little break. We'll go back to proofs in chapters 8 and through the end of the year, but chapter 7 has no proofs, so there won't be any proofs on your 2 quizzes or your test. Chapters 5 and 6 had fewer proofs. But chapter 7 really has none. So all of these new theorems you won't have to worry about memorizing to put in a proof. They'll just be all algebraic problems. So the examples tell whether the given triangle is a right triangle. And so you're going to look at this and decide which one is the largest side. And let's see, 13 is close to between 9 and 16, so that's probably about 3.5, and so 3 times 3 is bigger than 9. So even without just looking at the picture, we don't want to assume just because this appears to be the longest side that it is. 3 times 3.5 is going to be more than 9. So now I know that I want to put the c squared, or the biggest side, here. So we have 3 radical 13. Is that equal? I have to say, I say that I don't love a lot of things in your text. I do love that they put the question mark over the equal sign. That's great. So is this squared equal to 6 squared plus 9 squared? Now let's remember with radicals, whenever you have a times b squared, that's a squared times b squared. So 3 squared is 9. Radical 13 squared is 13. You don't have to write this, but just quickly, radical 13 times radical 13 is going to give you, the radicals will cancel, is going to give you 13. All right, and so here we have 36 and 81, and we end up with 117 is equal to 117. So yes, this is true, and that means the triangle is a right triangle. Let's try the second one. It's easy to tell that 29 is the largest, so I'm going to put 29. Is that equal to 24 squared plus 16 squared? Is 29 squared equal to that side? So I have 841 and 576 and 256, and we get 841 is not equal to 832, and so this is not a right triangle. And that would be really, really easy if they stopped there, but we can get more specific. We have some more theorems. Again, they won't be in proofs, just algebraic problems. If you end up with the largest side, the longest side squared being less than the sum of the other two sides, that is going to give you an acute triangle. And so if you can show that, you have an acute triangle. And then the reverse is true. If the longest side squared is larger than the sum of the other two sides squared, you're going to get an obtuse triangle. Okay, so now not only can we, on the last problem, it just said, are they right or are they not right? Now they can say, we classify the triangle by its angles, because you can say that it's not just right, or not right, you can say it's acute or obtuse. So let's look at example 2. Now the next question says, can segments with these lengths form a triangle? If so, would the triangle, there you have it, be acute, right, or obtuse? So I love this little reminder over here that says, don't forget the triangle inequality theorem states that the sum of the lengths of any two sides of a triangle is greater than the length of the third side. Otherwise, it won't make a triangle. So I'm going to take the two smallest sides add those together, is that bigger than the largest side? So the 4.2 is the largest side, and that's yes. So we can make a triangle out of this. I'm not 100% sure why they have you do it with each one. To be honest, I would just do it with the two smaller ones, add it, is it bigger than the biggest one? But let's go ahead and fill it in. And so 7 is bigger than 3.2, and 7.4 is greater than 2.8. And so even just with this first one, I already know it can be a triangle, and then it says to classify it. So instead of putting are these equal, they left it completely blank because the question is it going to be equal, less than, or greater than that we're going to fill in there. Okay, so let's fill in the biggest side is 4.2. 4.2 squared. Is that equal, less than, or greater than 2.8 squared plus 3.2 squared? Okay, and if you go to your calculator, you get 17 and 64 hundredths, 7 and 84 hundredths, 10 and 24 hundredths, which gets you 17 and 64 hundredths on the left side, 18 and 8 hundredths on the right side. Clearly, 17 something is less than 18 something, and if the big side is smaller, you end up with, if the c squared is less than, you end up with an acute triangle. Okay? So, let's do another example, and this is actually, does kind of introduce another concept. So, it says you're helping install a light pole in a parking lot. When the pole is positioned properly, it is perpendicular to the pavement or to the ground. How can you check that the pole is perpendicular using a tape measure? So, to show this is something new, let's star that. To show a line is perpendicular to a plane, you must show that the line is perpendicular to two lines in the plane. And that has to do with if a line is perpendicular to a plane, then it's perpendicular to every line in the plane that passes through its foot. The point at which the line goes through the plane would be called its foot. To prove it, you only have to prove that it's perpendicular to 2. But once you do prove that it's perpendicular to the plane, then it's perpendicular to the infinite number of lines in that plane. Okay, so let's get back to the problem. Think of the pole as a line and the pavement as a plane. Using the 3, 4, 5 right triangle and the converse of the Pythagorean theorem to show that the pole is perpendicular to two different lines in the plane. So you first mark 3 feet up on the pole and mark 4 feet on the pavement. Then you use a measuring tape to check that the distance between the two marks is, I hope, 5 feet, because you want a 3, 4, 5 right triangle. So when you measure this distance, if you get 5 feet, you now know that this line is perpendicular to one line in the plane. That's not enough. You have to have it perpendicular to two lines in the plane. And so we have one right angle. Okay, so it's perpendicular to one line, but it has to be perpendicular to another. So then you would use another line in the plane to have the 3 feet, the 4 feet, and the 5 feet. And if that's true, now you know that it's perpendicular to another line on the pavement. Okay, so this is just kind of, this is another thing that I would star if I were you, because it's just kind of a good review of everything we just learned. We know that if the longest side squared is equal to the sum of the two smaller sides squared, we have a right triangle. If we have that equal sign, if the longest side squared is less than the sum of the two side squareds, we have an acute triangle. And then finally, if it's greater than, we have an obtuse triangle. So if you were studying for a quiz, this whole packet, this is kind of a good review. Just this one little piece is a good review. Okay, so here we are at the checkpoint, and I'm hoping you're going to stop the video. Please stop the video and try all 4 checkpoint problems. Alright, so I'm going to go ahead and just talk through what I did here. Again, I'm taking a look at which side is the longest. It looks like in the picture this side is the longest, but let's not assume that. The square root of 10 is a little more than the square root of 9, which is 3. So 2 times a little more than 3 is going to be a little more than 6. So clearly this side is longer. And so that's why I set it up with this being my longest side. And just like that first example we did, 2 squared is 4, radical 10 squared is 10, and then we're just going to solve it. 40 is less than 41. The longest side is less than, so it's an acute triangle. In this case, I'm going to do the same thing. Let's see, 61, it's kind of close, a little less than 64. So a little less than 8 times 3 is 24, clearly bigger than the 18 and the 15. So I feel comfortable putting this as the longest side over here. And again, I guess I should have put a question mark here because we don't know that yet. Set it up. 3 squared is 9. Radical 61 squared is 61. Fill the rest in. We end up with an equal sign. 549 is equal to 549. So this is a right triangle. Now, this is slightly different. It says, can these segments form a triangle? If so, would it be acute, right, or obtuse? So the first thing I would do is take the two smaller sides, add them together, and see if it's bigger than the biggest side. And it is. So my first answer to my question, yes, it would form a triangle. Then I'm going to take my largest side squared. Is that equal? There's my question mark. Is that equal to the sum of these two sides squared? And I end up with, no, they're not equal. This one is larger, and since it's larger, that gives me an obtuse triangle. Finally, and my favorite one, I get to talk about triples a little bit, it says, in example 3, could you do the same thing with 50 inches, 120 inches, and 130 inches? And so the first thing, just in my head, I thought, is 50 plus 120, is it greater than 130? And of course, 170 is greater than 130. So yes, we can make a triangle. So I drew a sketch, and then I hope you see that if I divide everything by 10, I have a 5, 12, 13. 50, 120, 130. If I divide by 10 is a 5, 12, 13. And right there, I don't have to show any more work. I have a right triangle because it's a triple. Okay, hope that helped.